Today we are going to solve quadratic inequalities algebraically. So before we get into our inequalities, I want to remind you of one thing, and that is if you multiplied a number by another number and ended up with a product that was positive, you know that either these two numbers were positive or they were both negative, because the product of two positives is positive, the product of two negatives is also positive. We also know that if we multiplied two numbers and ended up with a negative product, that one of two things is happening here. This is negative. That we multiplied a positive by a negative or a negative by a positive. So same sign, the product is positive. Different signs, the product is negative. So let's say we wanted to solve the inequality x squared minus x minus 6 is greater than 0. Now we can actually see the solution graphically. We want to know when this function, this parabola, is above the x-axis. When is this positive? So our function is positive here and here. And it looks like this is starting at -2 and that this is 3. So we already know graphically that the solution should be that our function is positive from -infinity to -2 and positive from 3 to infinity. Right? Positive from -infinity to -2 and again positive from 3 to infinity. So let's see if we get the same answer algebraically. So here's our inequality. The first thing that we're going to do is factor. We can write this as x minus 3 times x plus 2. Now what this says right here is that if we multiply a number times another number, right, we've got a product here, that the product should be greater than 0. This means positive. So a number times a number should be positive. So we know that these signs have to be the same. Either this is positive and this is positive, or this is negative and this is negative. So we've got two cases. Let's write those cases down. We've got case 1 is that they are both positive, and case 2 is that they are both negative. Now we're going to write this down symbolically. If we want to say that x minus 3 and x plus 2 are positive, what we're really saying is that x minus 3 is greater than 0 and x plus 2 must be greater than 0. Whereas if we want to say that they're both negative, we would say x minus 3 is less than 0 and x plus 2 is less than 0. Okay, let's just focus on case 1. If we add 3 to both sides, we get that x is greater than 3. And if we subtract 2, we get that x is greater than -2. So now we've got to simplify this. We want all the numbers that are greater than 3 and also greater than -2. Now what I like to do is to draw a number line. Here's our -2, here's our 3. Here are all of the numbers that are greater than 3. Greater than 3. Then we want all the numbers that are greater than -2, and those are right here. Here are all the numbers greater than -2. So the numbers that are both greater than 3 and greater than -2 would be from 3 to infinity. That's where we have this overlap here. So I'm going to write that using my interval notation, that the numbers that are greater than 3 and also greater than -2 are 3 to infinity. Okay, let's go to our second case. We're going to do the same thing. We're going to add 3 to both sides. We get x is less than 3 and subtract 2, and we get x is less than negative 2. So where are all of the numbers that are less than 3 and less than negative 2? Here's negative 2, here's 3. Numbers less than 3 are here. Numbers less than negative 2 are here, and here's the overlap. So here we have all of the values that are less than 3 and less than negative 2. So that would be all the way from negative infinity up until negative 2. And that turns out to be our solution. It's the union of these two sets. So negative infinity to negative 2, or 3 to infinity, which is what we saw graphically on the previous page. So what if instead we wanted to know where x squared minus x minus 6 was less than or equal to 0? Graphically, we can say that our function is less than or equal to 0 between negative 2 and 3 and equal to 0 at negative 2 and 3. So our solution to this would be from negative 2 to 3. That's where our function is at or below the x-axis, less than or equal to 0. So we're going to solve this algebraically and hopefully get this solution. So here we go. We've got x squared minus x minus 6 is less than or equal to 0. Same as we did before, we're going to factor. We get x minus 3 and x plus 2. It's x plus 2. Now we have a product. Here's a number, here's a number. This number times this number should be less than or equal to 0. In order for the product to be negative, these two numbers have to have different signs. So this could be positive and this could be negative, or this could be negative and this could be positive. So those are our two cases, and we'll write that down now. So case 1 is going to be that one is positive and the other is negative, and case 2 is going to be that one is negative and the other is positive. So the way we write that symbolically, here's case 1. The first number should be positive, and the second number needs to be negative. Case 2, first one negative, and second one positive. Okay, focusing on case 1, and x is less than or equal to negative 2. Okay, so now we've got numbers that are greater than or equal to 3 and less than or equal to 2. If we take a look at a number line, here's negative 2, here's 3. Here are the numbers that are greater than or equal to 3. And here are the numbers that are less than or equal to 2. Notice that they don't overlap. We don't have any numbers that are greater than or equal to 3 and also less than or equal to 2. So here for case 1, there's actually no solution. That's not possible. But case 2, looks like this. Here's our number line, negative 2, 3. Numbers that are less than or equal to 3 are here. Numbers that are greater than or equal to 2 are here, and they're overlapping in the middle. So our solution is negative 2 to 3. And that's our solution to the whole problem. Case 1 didn't work out, but case 2 gives us negative 2 to 3, which is what we saw graphically. And here is our summary. In order to solve quadratic inequalities, you want to factor the quadratic. Then step 2, you're going to set up your cases based on whether the product is positive or negative. So if the product is positive, that's greater than 0 or greater than or equal to 0, you know that your cases are that both are positive or that both are negative. And then if your product is less than 0 or less than or equal to 0, your two cases are that the first is positive, the second negative, or that the first is negative and the second positive. You solve the inequalities that you created, and from that information you draw your number line that's going to help you determine your solution.